Hello, my name is Kevin Welsh with Innerspec Technologies, and I'm here to provide you with a brief demonstration of thickness measurement using EMAT with the Teammate PowerBox H. Now, before continuing this video, if you're new to the Teammate PowerBox H system, I would strongly encourage watching our introductory video prior to this presentation. Now, let's begin. Ultrasonic testing is the technique of choice to measure thickness when there's only access to one side. However, conventional piezoelectric systems generate the sound in the transducer, which has important drawbacks. Conventional UT techniques require couplant and are not appropriate for hot or very cold applications. The practicality of the test is greatly affected by surface conditions. It is estimated that more than 50% of the time used on UT thickness measurement is spent on surface preparation. And successful testing is affected by the angle of incidence and the orientation of the transducer. Electromagnetic acoustic transducer, or EMAT, is an interesting alternative that addresses these problems. EMAT is a dry technique, making it ideal for harsh environments where high and low temperatures make it difficult or impossible to use couplant. The EMAT sensor can generate sound through rough, painted, and oxidized surface conditions without surface preparation. Additionally, the angle of incidence is not a factor, making EMAT ideal for curved and irregular surfaces, such as tubes and pipes. In order to properly conduct any test with the Teammate PowerBox H, it's important to ensure you have all of the required components. Now, many of these components do come standard in our kits. However, some tests do require additional sensors, tuning modules, and other accessories. You can find a complete list of components for all testing methods in the Innerspec Standard Sensors and Accessories catalog. For today's thickness measurement test, you will need the following items: a Teammate PowerBox H, a single-channel 2-pin RF coil cable, a large permanent magnet, a thickness measurement application sheet, the Teammate PowerBox H user's manual, and an RF coil applicable to the material of your testing sample. For this test, I'm going to be using a carbon steel calibrated standard. However, thickness measurement using EMAT can be conducted on a variety of both ferrous and non-ferrous material. According to the thickness measurement application sheet, I'll be using a PE LS .730 by .025 coil. You'll also find the required setup information in this document, including setup files, signal conditioning data, and frequency information for this coil. But we'll get to that in a little bit. Now that we have all of the materials together, let's work through the basic setup of the Teammate PowerBox H. To start, you'll want to ensure that all the required accessories are assembled and connected to the device. This includes mounting the RF coil to the required magnet, connecting the sensor to the device, and then powering on the Teammate PowerBox H. Now that you have everything connected, you're just one easy step away from beginning your thickness measurement test. That step is device configuration. Once your Teammate PowerBox H is powered up, you'll find yourself on the home screen. There are a variety of different tab options available on the screen, but they're not necessary for basic thickness measurement. Today, we're simply interested in the open button. Once pressed, you'll need to use a combination of the scroll wheel and checkmark OK key to navigate to the folder entitled Setups. After selecting Setups, you'll then need to select the folder Thickness Measurement, where you'll be presented with a variety of setup files. It's at this point that you'll need to go back to the thickness measurement application sheet to determine the correct setup file for your material and sensor. For my sample, the material is carbon steel, which has medium conductivity and a thickness that I estimate to be less than 50 millimeters. With that in mind, the TM-MC SH1 to 50 millimeter setup file will load the recommended settings for this ferromagnetic sample. See the tips below for information on how to select the right setup file for other samples. Now that we have determined the right setup file, highlight it on the file browser and select by pressing the OK button to load the setup. Once this is selected, your Teammate PowerBox H will be ready for testing. To begin, carefully place the sensor on the testing surface and press the play button to begin analysis. You'll quickly see the A-scan displaying one or more back wall signals, and it will provide you with a default metric reading of the thickness. As I move the sensor freely along the sample, the thickness reading is continually displayed, and a strip chart can be activated to display the thickness trend. Another great benefit of thickness measurement with EMAT is that the measurement is conducted completely free from the use of couplant. Unlike other ultrasonic thickness measurement devices, EMAT sensors are tolerant to changes in sensor position while maintaining accuracy. That gives this device superior thickness measuring capabilities in less than ideal conditions. Additionally, EMAT allows for sensor liftoff of up to 12 millimeters, allowing for penetration through paint, rust, and other surface conditions. Well, that's it. You've just finished the thickness measurement tutorial, and hopefully results came out as clear as mine. In the event you had any difficulty recreating this thickness measurement with your sample, be sure to review the setup file parameters located in the thickness measurement application sheet for additional filtering and setup information. It's important to note that this demonstration barely touched on the many advantages available using EMAT for thickness measurement. If you'd like to learn more about the many other advantages of this technology, including high temp and low temp analysis, high-speed measurement, and completely automated applications, visit our website at www.innerspec.com.